Here you go. Cool. Let's go ahead and just hook you up.
All right. Cool. So Teensy 4.0 is out. It's 600 megahertz now, and Arduino compatible, all the fun stuff, and less than $20, has like everything under the sun that you might want out of like a chip. So like crypto and I mean I don't even know what else is out in it, but like it's awesome. Everyone's excited. Yeah. Anyways, Teensy 4.0. Cool. Cool. All right. So.
Anybody else have anything, or is that you want to show you everything?
No.
Any other show bill? All right. Well then, without further ado, Shritesh Bhattarai.
All right. Cool. So I will, I guess, sit in front of the computer. Is this fine? Or do I have to stand? Cool. So everyone, thanks for coming. All right. Cool. So I'll do like probably like a 10-minute like presentation, like slide stuff, talking about like how to look into Zig, or like what like mental model or like framework that you might want to have when you're like approaching Zig, and then like the middle part will probably be like tons of like code samples, and like just feel free to like just ask questions if you don't like get what's going on or something like that. And then the last one would be like some demos of Zig running on like different platforms. So all right, so let's talk about programming languages first, right? So how do you like describe a programming language? Do you talk about like syntax, semantics, or like paradigms? Wait a moment. Cool. Yeah, this is what I wanted. Right. So when you're describing a programming language, do you do like syntax, semantics, and paradigms, or do you talk about if something is like curly brace language, or like if it's like indentation based like Python is, things like that. And like paradigms when you're talking like functional, imperative, object oriented, and like you can also talk about like the features that a language has, like what killer libraries and frameworks it has, such as like Ruby on Rails when it comes to Ruby, right? Like that one framework just made the language like so widespread as it is. And then you can also talk about like history and culture of a language, where it comes from, like when you're talking about like COBOL or something, like it came from an era where like they had certain constraints, things like that. Fortran, right? You can also talk about like community and commercial backing, right? Like so the Node.js JavaScript community is massive, so you can like judge a language or like describe a language like that, or like who's backing the language, like is it .NET like Microsoft, C#, and like Apple Swift, or like what are the real world applications written in a language. So you can like describe a programming language in like a lot of ways. But like what I like to do is like what you can and cannot do with a language, right? Like everything else comes after that. It's like to consider a language, if it's the right fit for you, you have to like see what you can and cannot do with it. So like take example of C, right? Like we all know C. It's been around for quite a while, and like it's like almost everywhere. Like in Nash Micro, I would assume like everyone just writes C as their primary language, or assembly, but C. So what can you do with C, right? It's like you can write programs for like tons of platforms, and like there is a compiler or like a tool chain like for every like platform out there in C for sure. And when you're looking to write C, most of the time you're looking to write like performant code, right? Like there is no garbage collection. They can be used for like real-time operations, and like you can write an operating system with it. That's when you consider C, right? And then when you want like full control of the hardware, so like pointers, registers, assembly, right? Like everything goes. You should be able to do everything that is allowed by the hardware in C. And then also like access low-level hardware, same thing, right? So like you should also be able to interface with other programming languages. That's when you consider a language like C, right? And then like every language essentially can like talk to C or is probably written in C, right? But like where does C like fall short or is probably not the right choice is like when you want to reason your code with confidence, right? It's like you see some C code and then inside your head you need to run like a compiler thinking like, hey, what is this code doing, right? Most of the time like the problem that I see with C and like C++ and other languages is like there is this another step inside your head, right? And then you see like some bit flips going on and like typecasting going on and like, they are not communicating their intent. So if you're like, casting from a U size to I size or like, something similar like that, you are intending to do something else, but like you're writing it in a different way. And another thing is like, build and use higher level abstractions. It's like you'll have to create your own like hash maps and like represent errors a certain way, and like, business logic just gets reduced down to like the base C types. And I think like this is where C falls short. And also, right, like writing secure code is like, Microsoft said something like 73% of all their like bugs are memory problems caused by C and C++, things like that. It's really hard to write secure C code. Yes, people can do it. There are certain people that can do it, but like, like when you're writing secure code, C is probably not the first language that comes to your mind, right? And like sharing code between projects and ecosystems. So like everyone has a different way to compile C. There are like CMake, automake, .configure, right? Like there's so many ways, and like package managers, right? Like the package manager that you use in like Windows, if there is any, I haven't used Windows in a while, but like on a Mac, there are like multiple package managers on a Mac, and then you get into something like pkg config, right? Like it's just a lot of like problems when it comes to like sharing code. So, if we're talking about a language that's to replace C, right, it should essentially fix those problems, but also, cater to all the use cases that C already supports, right? So that's where Zig comes in. Zig is an open source general purpose programming language, right? So it's the main creator is Andrew Kelly, and there are about, last time I checked, there are about 135 other contributors on GitHub. It started in 2015. We're in 0.4 right now, and 0.5 will be released end of this September. It follows LLVM, the low-level, or at this point, it's just LLVM compiler infrastructure. So like anytime LLVM gets released, a new version of Zig comes out. So the next one will be in like 6 months after this. And the focus, or like essentially like the slogan of the language is like robustness, optimality, and maintainability. Like, this is like the core, I guess, ethos of the language. So again, right, like using the same like framework that we looked at C, what would you use Zig for? Like you would write secure and performant code. So like, unlike C, this brings in safety, and like there should be an asterisk in there, which I'll come back to later. And it's performant because it uses LLVM, like the same thing that Clang uses, like cutting edge, state-of-the-art compiler, as like all the good stuff, right? And it lets you reason about what your code is doing at both compile time and runtime. And we'll see some demos of this. But like what I mean by this is like there are no hidden control flows, right? Like so you can look at the code that you see in front of you, and you will know what it's doing. It's not going to be certain hacks or something like that. If it's like, a wrapping addition, right? Like you will see a wrapping addition there. If it's doing like overflow, you will see an overflow there. And like, unlike any language like C++ or like Java or something like that, where, calling an operator or like using an operator might invoke a function, that's not going to happen here. It's like if you see a function with parentheses around it, that's like the only time a function ever gets called, right? So like, it's a really simple language, and again, I'll come back to this. And it'll let you use higher level abstractions. So like tag union, errors, optional types, sets, bit fields, right? You can represent them really well. And to a certain extent, you can also use like interfaces or something like that, but this is what Zig allows you to do. And this is probably going to be the most popular thing of the day here, right? So instead of just being able to write for many platforms, you can cross-compile Zig to many platforms. So it's like sitting here on this Mac, I can cross-compile Zig code to something like an Arduino, a Raspberry Pi, a Windows machine, an OpenBSD machine, right? I can write a kernel, right, without having access to any of that, like straight sitting just here on this machine. And the same code will probably work. And this is going to be really important when there is a lot of existing C code base out there. It integrates with C libraries without any overhead. So like you don't have to write wrappers around things or none of that, right? And there is even like a trick up Zig's sleeve where you can see like, it works really well with C compilers. So again, where does Zig fall short right now is if you're using it for production today, right, like the language is still evolving, there are breaking changes happening, right, like, so Andy has said, like, it'll be like, stable 1.0 in a year and a half or something like that. So we're getting there, but like a lot of pieces are still being built. Now, one caveat that I mentioned before is like memory safety, right? So in Zig, you can interact directly with pointers, and you can write assembly, and you can do a lot of like funky things that you would want to do in a language like C, but it also comes with like certain restrictions, right? And like, again, the elephant in the room here is Rust, right? Like, Rust aims to do a lot of those things and also guarantee memory safety, but that comes at a cost of additional complexity. So what Zig is trying to do is like, have this simple language and still give you a lot of memory safety, but like, there are certain places in which you're on your own right now, and there are certain issues. There are like 2 issues open on GitHub where like, as you'll see, there are multiple modes in Zig. There is a safe mode, there is a small mode, there is a debug mode, there is a fast mode, and it is intended that the that the debug and safe mode will be really safe. So that's still a caveat, right? But apart from these 2 things, I think Zig is capable of replacing C and doing it better. So demo time, right? Let's get into code. Famous last words, I guess. Cool. BR. Oops. Sorry. Oops. Forgot my notes. All right. Cool. Just to make sure I don't forget anything. Cool. So, can you see the screen? Mirror. All right. So I'm going to go to ziglang.org. This is the website, right? And then like download. And as you can see, the download, can you see the screen? Cool. So the downloads are like 37 megs, 42 megs, 35 megs, 31 megs. As I'm on Mac OS, I'll download this 35 meg download, right? So, cool. So I'll go to my downloads folder. XVZF Zig, right? So it extracted a lot of things. Cool. So I'm here. and there is the Zig compiler. I'll just make it easy for me to ln this s downloads Zig. Cool. So I have access to the Zig binary from anywhere now. That's all I did. So what I did was download this Zig binary, like tarball, and extract it, and now it's in my path essentially. So what I can do is look at the Zig version, right? It's 0.4.0, and then it's built out of this git commit hash. That's what it is. So let's go to my editor of choice, Visual Studio Code. Talk. All right. Demo.zig. Cool. Yeah. All right. So cool. So let's start with hello world, right? So we have pub function main, right? Void. So this is how you define a main function. In C, you would do something like void main, and yeah. So that's what this is, pub function main. Now Zig has certain like guarantees, which I'll come back to later. So instead of the printf function, right, we'll use what's called a warn function, which essentially prints to standard error. So to get a warn function, hello Nash micro, right? Yeah. So we'll do a const warn equals import std.debug.warn. So what this is doing is this is importing this std, or the standard library, and then inside that namespace there is another namespace called debug, and inside that there is a function called warn. That, like, I'm just bringing that to I'm bringing that to the root file, and now I can essentially call that function. So all I'm doing is just bringing that to the scope so that I can call it. Now straight off the bat, what you can see is let's run this. So let's Zig run, right, demo.zig. Hello Nash micro, right? It works. So straight off the bat, you can see you can, so you have to, this is like doing an include in C, right? You're including this, but we have namespaces, and importing files does not pollute your scope. So you can implement your own printf function, and it won't collide with libc or something, or you can even build your own standard library yourself, right?
Is the standard library at Zig, does it have to be provided and compiled for each microcontroller or each?
We'll get there. This is that gets into the fun stuff. That's like eating dessert before dinner.
Like desserts.
All right.
Did I see that the IntelliSense was picking up on the packages?
Yes. So in VS Code, so there is already formatter integration. Format and save is true. So form. Anyways, so yes, it usually works. I don't know what just happened here, but that's VS Code. That's not Zig. So I can do something like Zig fmt and demo.zig, and it will. Yeah, so it just formatted, but that's why. Cool. Now it will format. So if I have, so if I misindent it or something, it will just format it when I hit save. So you get uniformity. You don't have to worry about am I indenting this correctly or something like that. Zig format will tell you.
Visual Studio Code.
No, it's part of the Zig binary that we downloaded. So I could just do Zig fmt demo.zig, right? Fine. And what I love about it is like the way I've set it up in VS Code is it does that every time I hit Command S, right, when I do save. But so if I commit some mistakes here, I'm forgetting the semicolon, right? That catches that right away as I hit save. So that's really like helpful when you're, to catch bugs before they even happen, right? Like, so yeah, that's awesome. Cool. So, regular stuff. Are we clear on this, or like, are we not lost yet? That's all I care, right? Regular stuff. So let's go into something else now, or I'll just comment this out. You have double slashes for comments, right? So suppose, because I'm a good programmer, I write tests, right? And you're supposed to do TDD, yada yada. So let's write a test for something, right? Let's write a test for, like, let's say an add function, right? Let's say 2 plus 2 is 4, right? That's the name of my test, right? And then I'm going to bring something called I'm going to bring the assert function from import std.debug.assert, right? I could have also done like std and then done like std.debug.assert, right? And I'm going to write an add function later that says add 2.2, and then it should return 4, right? This is a test. So I can do zig test demo.zig, right? It says use of undeclared identifier, right? Like red, green, refactor, fun stuff. So I'm going to write a function, let's say a regular function, fn add, right? That takes in, let's say I8, and b is an I8, an integer with 8 bits. So like a short. Oh no, it's a car in C, right? I8 is, or U8 is a car, but you get size and
Color is undefined. It could be signed or unsigned.
Okay.
Depending on the compiler and the setup.
All right. So, but then,
Is fine.
yeah. So, but then we're explicit here, right? So, we're gonna return, or let's even make it more verbose. So, I'm gonna declare a variable called sum, right? You could either do like a var sum or a const sum, because I know I'm not going to change this sum after I've computed it. I'm just going to do a const. Sum equals a plus b. Now return sum, right? Now I can run the test again, and it passes, right? But let's say, I was doing, instead of doing add, I was doing a sub, like, I got it wrong. So if I run the test, now this is the fun stuff when it comes to Zig. Right, you get stack traces. First of all, right, the test failed, but then what you get is stack traces and like how we got there, right? So there is this keyword called unreachable that essentially creates a trap, and then like it unwinds the stack and it shows you how you got there, and it goes all the way down. And the best part is this is across all platforms. So even if you're writing like bare, Raspberry Pi, like bootloader code, you get certain features like these, and like I'll demo that later, or like sure.
Test is a native function type, not a third-party thing.
Yes. So test is a way to essentially create unit tests or like regular tests, and that does not get compiled when. So if I do like zig run like demo.zig, right? So, it does not even have a main. So, like this test block never gets called unless I'm calling the test command through command line, right? Unless I'm doing zig test, like this gets ignored, and we'll come to that too. So in zig, like let's see. So the only thing that gets called here is test, right? So let's say I have like a global var, like a global, let's say, like answer, and it's 42, right? 42. So when I run, when I run this test, and let's fix this first, right? When I run this, right? Because inside my test block, I'm not referencing this answer, this does not even get, like, the compiler will not even look at it. So the way this works in this language is like you have one entry point, right, or multiple entry points, and anything that gets referenced by those entry points, they get compiled. Everything else just gets ignored. So you're not paying the penalty for compile. Like if your source code is massive, right? I mean, parsing it will take some time, but like compiling it, you get dead code elimination by default because that code does not even get looked at unless it gets referenced. So it's pretty cool stuff, right? But like, you know, we're getting way ahead of ourselves. So, so similarly, like I think the easiest way to show this is like I run main, right? So it just happened, warn. So there's a main function, right? None of this ever gets looked at, right? All this does not get looked at. The main function, it only calls warn, does not do any of this, right? So it just gets ignored.
Can it, like const answer equals 42, that's what I would call dead code. Can it give me a warning or can it tell me that?
No, because there are certain things you can do here. So you can like literally check if like this is pseudocode, but like there's a way to do it. If platform equals like, you know, Windows, then do this, right? And else, you know, do something. And in that else block, right? So if you're not on Windows, right? The if platform equals Windows block does not even get looked at.
Sure, but forget that. If I have real dead code, can it warn me about that?
Yes. So let's say, like even here, right? So let's say you just did add 2 and 2, right? And you know, you're not using this code at all, right? The return value of an add is an I8. You're not using it. So technically the compiler can like, you know, like get rid of that. So when you run this, it's like, hey, that's an error. That's not even a warning, that's an error. You have to handle it, and you can handle it by doing something like this. So it's like, I don't care about it, but like, you know, I want this here. So yeah. So yeah, like Zig does not have warnings, it only has errors, and it will make you do the right thing most of the time. Cool. So we saw tests. Tests are good. Tests are part of the language here, and they're implemented in a really tasteful way, which I love here. Cool. So let's go to, so one of the biggest problems in C is pointers and arrays, right? Like it's so hard to differentiate whether something is a pointer or pointer to a single element or it's a pointer to an array, right? So in Zig, we have slices, and so Zig has slices and arrays, but Zig arrays are kind of different. So let's say, I'll say a variable world, right, like string, so like a C string, world is WRLD. Now, if you were in C, you would not be like, you know, to find the length of this string, you would do something like strlen, which has its own issues, right, all of that. But in Zig, you can do something like warn, right, warn. So the length of is, so if you're used to Python or something, or even, okay, even, okay, cool, yeah. So you can do something like the length of world is world.len, right? So yeah, the length of world is 5. So what this did was world is an array, and in Zig, in Zig, you have arrays and slices. Arrays are compile time, so it is encoded in the type system. The length of the array is encoded in the type system. So you could say something like array, let's assume if you're writing like C, struct array would be something like ptr, right? T, and then you would have something like len, which is an usize, right? So this is how it's implemented under the hood, and arrays are compile time, so this does not ever get put into your code. At the end, they get compiled away to regular pointers, but if it's a slice is a runtime array that has this structure built in. So you're not paying for the cost, but at the end of the day, it's doing the right thing. So something like that. Yeah, so are we clear with like how arrays are implemented and like, you know, why they matter and why they're better than C here? Cool, cool. So next, let's do some for loops.
How do I function take that array as an input?
We'll come there. We'll come there. So, okay, let's do that. So const world is world, right? So let's say I want the len. Let's create a len function that takes in a string, and a string is a const u8, right? So this would be a variable array or like a variable slice of type u8. This is how you would write it. Like a u8 is a car or char, but because this is a const, right? You would define that in the type system, and then you would return a usize. I could do return string.len. Where did I miss? Oh, pub fn. Cool. See, that's what I love. It's like it caught the error before I was even like thinking of compiling, just at the formatting stage, which is awesome. So I could do warn dash n, just do len of world, and that should work. Cool. So this is how you denote, and this is how you denote a slice, and arrays are just compile time slices.
So you didn't have to find a header, there wasn't a...
Yeah, nothing.
So it just went through, I guess pub is public?
Yes, I didn't even need that, honestly.
What is a pub?
So here, right? So inside the standard library, there are a lot of like functions, methods, whatever, right? And these are technically structs. We'll come to structs later. And this by itself, std by itself is a struct. Inside that struct is a debug struct, and inside that debug struct is a warn function. Now there are definitely more functions in there that are private and to the module itself, but like if I put a pub in front of a function, I can access it from the outside. Yeah, so I haven't done OOP in such a long while, so like there is an actual term for this, I don't remember. Information hiding.
Exported public.
Yes. Yes. So cool. So that's how you pass a slice, and if you're doing this in C, you would be passing a pointer and a length, right? But then this is encapsulated in the type system itself. So that's that's slices. Now let's do for loops, our favorite, I guess, thing in C, which people hate a lot. So let's have some numbers, and it's an array of certain length, right? Like I'm telling like the compiler figure out what the length is. I don't care. That's why there's an underscore. And let's say 1, 10, 31, 42, and 59, right? So this is an array, a compile time array of certain length. It is 1, 2, 3, 4, 5, right? Let's put a 5 in here and do a Zig run, right? But if I put a 4 in here, right, again, it's a compile time error. It's awesome. So, and then I don't even need to count. I will just say, hey, Zig, figure it out, whatever that is. This is how we define arrays. Strings are a special kind of array, so they have a syntactic sugar, but at the end of the day, it's like, suppose you're saying AAA, it would probably be like 65, 65, 65. They essentially go down to the same thing. So that's an array called numbers. Now in C, you would do something like for I is less than 0, I equals 0, I is less than number, or like len number somehow, and then plus plus I. In Zig, iteration is really simple, So for works differently than C. You take in something that can be iterated over. Usually it's a slice. I don't think there are other things that can be iterated over. Again, don't quote me on that, but yes. So let's say a slice can be iterated over. For numbers, we'll take a number, right, and then do like a warn what the number is, right? Cool, we did that. But what's even better is like, this is one of the many syntax, right? So the next thing I can do is I can even index by it. So I could be like, hey index, cool. So, you don't have to worry about whether you're keeping count properly or something like that. The language prevents you from committing mistakes here, right? And for is strictly for iteration on things that already exist, right? Numbers already exists, right? It is a collection. It is an array. It already exists. You want to iterate over it. That's why we have it here. Now, if we wanted regular while loop or like regular for loop from C, you would do that with a while here. So let's say var I, which is a usize, equals 0. And then I would do while I is less than 10. And then this is another syntax here. So usually with a loop, there is always a continue statement, right? Like you don't write a loop that does not change any state by the next iteration. So what you can do here is I plus equals 1, and then write your loop here. So that way, the loop runs, and then whatever needs to happen after.
So it forces you have to.
No, you don't. You can do while true loops too. That's fine, right? But then this, yeah, that's nice. So let's say warn again, just to show it works. I could do something like, yeah, that works. Cool. So, all right. We're halfway through whatever the language has to provide. So that's the beauty of Zig. It's such a small language. So next comes structs, right? So let's say we're building a circle struct, right? And then a circle has a radius of say f32. Semicolon. Cool. So yeah. And the way you would fn main void, the way you initialize a struct is const struct, circle equals circle, and then dot r equals let's say 2, right? So this is how you create structs. And what's missing from C is it's really hard to operate on structs. It's like you call in functions with structs. Suppose in C you do something like fn area, right? And then you would take in a circle and then return an f32, and then you would do return circle dot r into, I guess, pi r square, right? And then let's say 3.14. This is how you would do it in C, and you can definitely do that here too. Struct, I'll come to that later. So warn, let's say area of the circle, and oops, const warn equals import st. All right, yeah. The debug.warn. Cool. So it works. I don't know if that's correct or anything, but it's there, and we would just assume it works. Yes, and we'll come to that later. Yeah, there's a really nice test case that I've written. Cool. So this is how you do things. It's fine, right? There's nothing wrong with it. But a syntactic sugar that Zig provides is you can put this function inside here, and instead of calling circle here, you could do circle.area here. So there's no difference between whatever we did before, but what you can do now is just call circle.area, which is more ergonomic, I think.
You still have to supply the circle input.
Yes. So like, I mean, I don't think there's any other way to reference it without doing it. But what you can still do is circle.area and then call our circle.
So it doesn't have this pointer?
No. Let's say no for now, right? Let's say no for now. There is something called the this method, which is a field structure pointer, which means I can write something like this. So I could do at this, all right, which is the same thing. But what this gets into is like Zig has a compile time evaluation. So at the end, like this gets compiled into circle by itself. Yeah, so those are the same things. Yeah, and like this can be used and abused to do certain things, again, within the safety of the language, yada yada, but like, you know, we don't have to get there, right? That's like advanced Zig. So yes, now circle, that's fine. What we can also, another thing, is like in embedded programming mostly, you usually use bit fields. So you're like, you know, you have this one like number and then you're just ORing or ending, and like, you know, it's so hard to get right. But Zig has another trick up its sleeve. So I could have something like, let's say flags, right, which is a packed struct. And then let's say A is U1, B is U5, U6, C is U3. And then this gets compiled into the proper bit flag, and you can manipulate it the way you want. And Zig has arbitrary sized integers. So you can have anything from like U0 to, I think, U128.
What's a U0?
It's a null thingy. It just you're representing. Again, I might be wrong on that. There's definitely U1 to U128, but like, you know, you get the point. You have arbitrary sized I guess integers. So when you create a packed struct, it will only use like the bits that it actually needs. And like whenever I use flags here in my code, it gets compiled down to do the right thing. So this is one of the many like problems that C has, especially when it comes to like embedded programming, that it solves. Cool.
Reference that like an enum?
So same thing as here. So you could just do, let's say, let's do a test, right, just to make it easy. So, so var flag equals flags, right? And then best part is you can have default values in structs. So let's put all zeros, right? So I could just do like, yeah, this does the right thing. And then I could do like flag.a equals, say, 1. That's all I can do. So this should work. And like just the bit that is supposed to be flips. Yes, but also like it's packed, and then you can essentially cast it to like an integer if you need it, and it's fun. And you can do an extern structs. We won't get into that, but like this works really well when you're like talking with C code that expects things like this. So essentially like OR flags are really easy to implement this way, and they're more structural, so they make sense here. You're not second guessing what you're even doing. You can just inspect it and everything else.
Because U is unsigned? Is
Yes.
signed equivalent?
I'm not sure when it comes to packed structs, but like, again, I127 is definitely a data type that you can use. So my favorite, I guess my second favorite, or is it my favorite? I don't know. We'll figure that out later. So another feature is tagged union. So let's say I have a circle, right? And then let's say I have a rectangle. Struct rectangle has a length and a breadth, right? F32. So what I can do is create a shape which is a union of an enum, right? Like, it's a tagged union where I can have a circle be a type circle and rectangle be a type rectangle. Cool. So, and you have used unions in C probably, but like what this does is provide a really nice way. Let's say I'm creating a really nice way to like deal with this. Let's say I am creating an area function here, right? Pub fn area, and let's say self is a shape. Now, depending on the type that I am, right, like, or depending on the tag that I'm currently in, I could work on this differently. How much time do I have? Am I going out of time?
Sorry.
Hmm?
Oh, you got plenty of time.
Oh, okay, cool. I was just like,
You got another hour.
cool. Yeah, I probably won't take that. So I can like switch on self, right, like a switch statement, but this is really fun in Zig. So let's say I'm a circle, I'm a circle here. So what I can do is I can get the circle, shape.circle, and then I can get the circle and then do things on it. So if I were a circle, I would return 2 into circle, pi r squared, right? 3.14 into circle.r into circle.r. So what did I miss? I should have just read the line 14. The type. Yes. So, so what I just did here was I switched at what the tag I was in, and then when I was a circle, I extracted the circle and then essentially operated on it. So this is, in other languages, these are called tagged unions, algebraic data types, right? There are plenty of names for this, but to have something like this in a low-level language like Zig, right, it's really nice. And we're not even to the best part yet. So let's say it's in the main function. Let's say I have a shape equals shape, and then dot circle equals circle, and then I could have done it less verbosely, but gets the point across. So all I'm trying to do is get the area of the shape, shape.area. Cool. So switch statements in Zig are exhaustive. So if, because I did not handle the rectangle case here, right, like it's a compile time error. There is no way around it. I can do like else and then always return 0, but like, that's on me, right? So now, so 0.0, apps, 0.0, as F32, but, return, return. I can type today. Else, curly braces, yeah, much better. Cool, right? So if I were, let's do the right thing. All I was trying to show is like that it works. But like we are shape.rectangle, and then I can extract the rectangle and return rectangle.l into rectangle.r, right? No member named R, cool, L into B. That's what I love. Like, you get this feedback from the compiler right away, and it forces you to do the right thing. So yes, this is something you can do in Zig, and it's really powerful. Like, you use this all the time. I was implementing something like a state machine, and like this comes really handy when you're implementing a state machine, because when you're transitioning between state machines and every state has certain properties or data associated with it, and you have to be in that state, and like everything has to be verified at compile time. Like that's awesome. So,
Return type on code.
oh yeah, totally. So if I did something like return a string, right? Like that's a compile error. Yeah, expected type F32 found U28. Cool. So now 2 more data types, and I think we're good. So next comes optional types. So in C, you have null pointers, which has been claimed to be the biggest mistake in computer science and programming, the billion-dollar mistake, right? So let's build a linked list.
Sorry, we've had some fun with null pointers recently.
Okay.
So then the microcontroller perfectly accepts a null pointer
Yes.
as a valid memory location and just keeps on going.
So let's build a node in a linked list, right? And the way you do that is like, you have some data. Let's say it's a string pointer, right? String pointer, it doesn't matter, string, slice. So if you were in C, you would have like something like a void pointer and then do ugly things with it. In Zig, you can simply have a question mark in front of a data type, and it would be an optional type. So that's how you would represent null point, or like a pointer in an optional pointer in Zig, right? So let's build this node. I'm going to cheat some because I don't want to build a whole linked list, but I was just going to show how this is going to work. So node, and then I'll do data equals Z, and then next equals null. So this is how I'm going to represent this. And Z will be Y, and this will be memory of node Z, and this will be X, and then this will be and node Y, right? So what I just did was create 3 pointers, and then they link to some, and the last thing is null, right? So it essentially compiles down to the same thing as it would in C, but like, you get some safety checks, which I will demonstrate here. Let's say I want to create a print function, right, that takes in a node and then just prints whatever is after it one by one, right? So I would do something like, I will not delete that, I promise, next time. Import std.debug.warn. Cool. Line 7, pubfn. Cool. So I would warn with the current self.data, right? I would print that. And now when I want to reference this, what I can do is if, right, self.next, then I would extract this as next pointer, or like next node, and then call next node dot print, right? So this way, there is no, so like, if this was a null pointer, it would probably call like an else block, right? And so without extracting it this way, right, without introducing next node, there is no way to even reference that pointer. It's like, I cannot reference next node here. So null pointers don't exist now, right? Next node is invalid in this scope because next node is only valid inside this block. So that way you don't have null pointers here. Yes, you can create null pointers because, you can do into PTR in Zig, but like those can be represented and like controlled and managed, right? So you don't have most of the problems that you have with C null pointers and what, so let's node x.print. So what just happened was it printed the data on its current node. It checked if there is a next node. If next node is not null pointer, then it called print. So the next node now becomes y, and then it becomes z. When it gets to z, this becomes false, and nothing happens, right? So we don't have null pointers, no null pointer exception at all. I mean, let's try it, right? Like let's try to have a null pointer exception. So let's say next node dot warn, or like print, right? Like it's just use of not next node, self dot next dot print, and it would just say, hey, type is an optional type, something like that. You know, you're doing something wrong, right? So yeah.
And for the first node, self.next would be null, so that's false in the if statement?
Yes. So I could do something like else warn like done, right? So when it reaches the last node, right, it'll just do done.
So that little next underscore node up there, it just...
It extracted, so like this is, so the type of self.next, I can even like put types here, is a const node. I don't think I can put types there, sorry. So, but like, yeah.
It just took that right from self.next.
Yes, it converted this, right, into an const node, yes. So you can call print on a const node, but you can't call print on this. You can only, so you can only do an if, you could use an if, you could do a while, or there's something called or else.
What do they call that with the word
I don't know at the top of my head. It's just like, you know, I've been writing Ruby for so long, and like, you know, this is something that comes naturally in Ruby. So I don't know the exact thing at the top of my head, but it's a thing. Yeah, so, you know, null pointers are solved now, right? So last thing, before we get into the demo part of it, are errors. So in C, you have like error numbers, and like, you know, errors are handled awfully in C, right? Like it's so hard. There is no proper like data structure on how to handle errors, and like, you know, and the reason we've been using warn here, right, is because writing to standard out can fail, right? So an ideal hello world program in Zig, I would just copy from this at this point. I think this is 10 now. No, that's 9, right? So this is what like a comparable hello world program in Zig would be. So you have std, but then you would try to get the std out file, because guess what? In microcontrollers and stuff, there is no std out, right? So, you know, this can fail right now, right? And then even writing to a file can fail. std out is a file, right? You can never guarantee that it's going to pass. And if you notice something here, we have an exclamation here, right? What that means is, like, you know, this function can return an error. So let's say we have, you know, guess the number game, right? Like I'll come back to this, but let's say we have guess the number game, and let's say a random number is 4, right? XKCD reference. I don't know if it's 4 or 42, but anyways. So, and we have a function called play, right? And then it takes in an input of const u8. It takes a string, and then let's say it returns void for now. But like when you're playing guess the number game, there are different things that can happen here, right? So const, like, you know, we could have parse error, right? So I might have, instead, like this is a string, so I could have sent in like potato, right? How do I handle that, and how do I represent that? In Zig, you have an error union. So this is an actual set of errors. So parse error could be like not a number error, right? It could be anything arbitrary, not a number error, or it could be too high number, or like out of bound number error, right? Something like that. And when you're dealing with the game, right, you can have game error where you can represent like saying the number is too, or like guess higher or guess lower by something like game error. It could be like too high or like too low. So what you can do here is return an error that's a union of parse error and game error. I might have gotten the syntax wrong, which I definitely have, but I think it's called this. I need to look at this, sorry. And Zig's documentation is amazing. Just like it's one page HTML that you can like save to a file, and there's still some like rough edges, but like it's awesome. Error. Yeah, error sets. So how do I? Okay, anyways, so I could just put a, I could just put this here, like a exclamation mark, and it will figure out what errors this can throw. Let's say if like input 0 equals A, then I could just like return, let's say parse error dot not a number error, right? And then I could do something like if input 0 or like 1, I'm just making everything up right now. So you know what I'm saying is you could represent errors like this in Zig, and what it forms is a union between two different kinds. And in programming languages, I have not seen union data types being used this well, but like it just gets the job done. And in my main function, I can just handle, so like, you know, I could do a, so let's say I have something like or like play, I just return a bool here, and then const success equals, right, play, and then let's say 1, 2, and then I can like catch the errors, catch error, and then I can switch on the error, and I could be, hey, if it was a parse error, then I could do something like this. If it was some other error, right, after pound number error, then I could do something like this. Else, I could just return the error itself so that it propagates to whoever is controlling it. So this is a really nice way to deal with errors in Zig. And if we look at our like previous example here, right, that's what this is doing. It's trying to read from a standard out file, and then this might error out. It will return certain errors, and then I might handle it here saying catch ERR and doing something with it, right? But like if I don't, it still works, it's still ergonomic, and I get to use the try keyword here so that the errors get propagated, and same goes here. And when you're writing Zig, most of the time this is what you do. You would write the happy path and then essentially handle the layer error if it makes sense to handle right now, or just propagate it up. So usually like the main function will have lots of error handlers. And then depending on what layer you're in, you would handle certain class of errors, certain types of errors. So this is, you know, again, it's a really nice way to represent errors, but it takes a while getting used to. And so what this tells you is like this function returns a bool when it's a success, or as in like when no errors returned, but like when the bool makes sense, it's the value that you're looking for. And then you extract that by using try. So that's like almost all the language, right? Like there's still like differs, error differs, like things that help with, I think there's just like 2 more things, and we will go through them like later, but at this point, like, I think you can write as much that you could write with C with just these, except like, pointers, and once you look at the documentation on certain functions, like, this should be enough to replace C, I think. Now let's look at some cool demos.
Often with hardware, you got to write to a specific memory address, do things that would generally be compiled out, unless you use like a...
Yes, so like a volatile, yes. Yes, so in Zig, there are definitely those things. Let's say volatile. Let's look at the, yeah. So volatile should only be used in like memory mapped input output, otherwise it is guaranteed to do, so if you're storing it in a stack or something, right, if you're storing the return value in a stack, or if you're writing assembly, it will do the right thing. But if you're writing memory mapped IO, Zig also has a volatile keyword right here. It's that you can use on pointers, I guess. So, again, as a language that intends to replace C, those things exist. Like, you won't be left out. But what's even better is, let's look at the operators, right? And this is something I love. So operators in C, so like the addition, signed are guaranteed to be overflows, but unsigned are not, or like it's the other way around. We don't know, right? But in Zig, this is what I love about it. It's like we had an overflow or a wrapping addition. We have wrapping subtraction, wrapping multiplication, wrapping division, right? And a lot of other wrapping operators. What's even better,
So you don't have to reboot your Boeing 777 every 20 days because of the overflow.
and yeah, so Zig also has compile time evaluation, which is a bit complicated, right? But what it also lets you do is at compile time, you can concatenate arrays, because it is done there. You can multiply arrays like n number of times, right? There are certain operations that you can do at compile time, and there is something called comp time, which is insanely powerful. So it has a platform-specific interpreter that runs at compile time. So you can run some code here, right? You can do awesome things, and it will be running it will showcase the exact behavior that you expect to see in the target platform that you're compiling for. Really cool stuff. Like there are people that so I recently saw a package in Rust that tries to mimic this but does not do it to the full extent. So at this point, I don't think there is any other language that has the compile time evaluation semantics of Zig, and it gets even better. We have generics because of that. So at comp time, you can pass in a type, right? This only gets evaluated at compile time, and then like the list that I just showed you before, you can essentially have a generic list because of these compile time semantics. Now to get through all of this, it's going to be a lot. So all I'm saying is it exists, it's awesome. Go check it out, right? So let's start with some demos talk, right? So let's start with this awesome project called Oxid. Okay, let me show you. Just I'll do a hello world one last time. So let's say last, right? So the way you would start Zig code is you would do like an init.xc or init.lib, right? If you do an init.xc, it creates certain files for you. So it creates a build script, right? Where you can set build modes and everything else here. And then you can have steps on how to install. So you don't need something complicated like CMake, AutoMake, yada yada, right? You can deal with what platforms to build for, what else to do, everything from this build.zig file. And usually so you've got the main.zig file, so you do something like zig build run. and then it will do the right thing. It knows how to do this. And if you have like lots of libraries and everything else that you have to compile, you would just list it all here. Now, let's go back there. So, Zig build. Zig has its own build pipeline. Zig is also going to have its own package manager where you can distribute C code, and that's going to be awesome. So let's look at this project called Oxid, right? So it's fairly complicated, but what I'm looking for is Zig build play, right? So it has tons of libraries that it uses, and it's a video game, right? Things you'd make in like C, right? And it's using tons of C libraries under the hood, right? And it just works because Zig has awesome like C compilation stuff, which I'll show you in a minute. That was the last thing I wanted to show you. All right. This does not make any sense until now. So let's go back to demo, right? Let's look at main.c, right? Regular stuff, C file. Now, if you look at Zig, when you hit Zig, you see lots of features, or like, options. And there's this curious Zig CC, right? Zig CC, and let's do a version on this. It's literally Clang, the C compiler from LLVM project, right? And this came directly from the 40 meg download that I did, right? Everything in it, right? Like that I just showed you until now. I have not installed anything else, right? Everything is in that 40 meg download, and then I can do like Zig CC main.c. I mean, like, I need to work on that, but even better is I can do something like build xc, right? And then C source main.c library C. So I just compiled C from the Zig compiler. So like there is no reason for you to not use Zig now. Like don't ever write, like if you're compiling C, compile it with Zig, right? But what this gives you is a lot of benefits. So now, right, I'm compiling C code, right? I'm going to set my target to be x86 64 Windows MSVC. Sorry. So, what? Fail. So I think, yeah, so this works, but like, I think 10.zig, let's see, cat 10. I just don't have the flags. If I was using like the build pipeline, I could have done it. But like here is a guess the game, right? So let's zig run 10.zig, right? As a guess the game number. And as you can see, I'm running on a Mac, right? So let's see, 20, guess higher, 50, lower, 30, higher, 40. Yeah, so 40 was the number, right? There is a guess the game file, code.or dot, let's say 10.zig. So, Zig code, the like errors are handled, right? Like even out of memory errors get handled and all of the fun stuff. So regular stuff. So Zig run 10, that's fine. Now what I can do is I could run it in release fast mode. So it took a bit longer to compile that, but it created really efficient code, and it also disabled all of the safety checks. So like, Zig has undefined behaviors that are controlled. So I think undefined. Yeah, so there are certain safety checks that are provided by the language. So Zig can be as safe as something like Python if you're compiling it in release safe mode, right? All of the compiler safety checks are in place. Out of bounds would crash your program instead of doing the wrong thing. Like overflows are handled. Like there's a tons of details that are provided in the, yeah, so these are all the undefined behaviors that are handled by the language if you compile it in safe mode. So suppose you're writing a web server, then you would do it in the safe mode, right? So that like, you don't get remote exploitation and all of the nasty stuff. and you would not write assembly, inline assembly. But if you're building, say, a video game that we just saw, right? I mean, it's not going to be used for like something mission critical or something, and like, you know, it probably won't be exploited. That's the way I'll put it, right? It's not an exploitation target. You want all the performance without any of the overhead that like other languages provide. That's why you're writing Zig in the first place. So then you would do something like release fast, but like say you're compiling something for like WebAssembly, which I'll show later, and then you would do something like release small, and you might even do it for your hardware, right? Like where you have done safety checks. And something I just missed was you can have a scope-based safety checks enabled. So let's say you're doing, so here's a function, right? Pub fn dangerous, right? You're doing something dangerous here. So what I can do is like at set safety something, set runtime safety. So I could just say set runtime safety to be true for this scope. So I can still release in like release fast or release small, but get all my compile or like runtime checks inside this scope. So inside this function, if I have like an out of bounds array or like something like that access, or if I do if I get an integer overflow when I'm not wrapping, this would do the right thing, right? Essentially crash and not cause issues. It will unwind, clean up all resources and all of the fun stuff, but the rest of your program will still be fast. So and like the inverse of what I just said, what you could do is like suppose you have you know, a web server that's written in Zig, but then inside this hot loop, right? Then you can like disable safety and manually like, you know, audit your code. So Zig lets you do both of those. So yeah, and where was I getting at? Cool. So yeah, so let's release fast, not run. I will build xc 10.zig release fast. Now I can specify target x86 64 MSV Windows. As you can see, I have a 10.exe. So let me do that again because it was already there. But like, I have a 10.exe here, right? And I have VMware Fusion running right here. So I'm booting up a Windows 10 VM.
How large is it? Go back to ls-l?
That's awesome. So 10.exe is like less than 9K. Hello World is 4K. So that's pretty awesome.
Can you just do file?
Oh yeah, totally. And I'll do that later for things that I can show you. So yeah, I mean it's a Win32, Win64 thingy. It's all stripped down. I think that's the thing. So cool. I guess this is booted up, right? I think I'm using the test VMs that are provided by Microsoft. So let's go to developer. Ooh, that's ugly. What am I doing? Talk. So demo, and then we have 10.exe, right? Let's say guess.exe. So, and then I will move it to my public directory. Cool, right? I have guess.exe. And I will run cmd and then open this public, right? I have guess.exe, which I just compiled, download it here, and voila. I just compiled, you know, a Win32exe from my Mac, and it knew what MSVC was, Microsoft Visual C compiler was, and like, you know, handled everything perfectly. I didn't have to do anything here, right? It just worked. So
Apple police are going to be after you. The Apple police.
Which
MSVC. I don't know. So I'll tell you what's going on here. So if we look at Zig targets, that 40 meg download contains all of this. It contains the compiler architectures for ARM, everything under the sun, Arch, AVR, RISC-V, RISC-V32, yada yada, everything, right? That's just the architecture. Now, operating systems, freestanding is like no operating system and everything else, right? Now, it's saying that Mac OS is my native, but like, usually I can compile for Linux and Windows, and there's a tier system that I'll talk about later. And this is awesome. It even ships with tons of CABIs, application binary interfaces, right? Like GNU, like all of this. And it also ships with tons of libcs. So I can compile for x86-64 Windows GNU, right? That's what I was supposed to do instead of MSVC when I was like showing it to you. And then it also ships with tons of glibc versions, right? All in that 40 meg download. All of that. Everything is self-contained. And first, so if you didn't notice, like the first time I compiled, it took quite a while. And then every subsequent ones were faster. So what was going behind the scenes was like, it has all these header files that was downloaded with it, and then it compiles once for every target the first time you use it. So like, now this gets even more interesting is, let's look at the game that I just showed you, right? Talk, and then Oxid. So Zig build, I'm going to compile it for WebAssembly now, right? The game that I showed you before. Now I'm in web, and then I'll run an HTTP server, right? So I could go to like localhost, I think it's 8080. Yep, the game is running inside my browser, right? This is how, and again, all from that 40 meg download, right? It has a web. Convert it to JavaScript? To WebAssembly, and then there is some like JavaScript shim in here, but and that's handled as build time in the build.zig file. So, but yeah, like this is running inside my web browser. And that's awesome. Cool. All right. Now, like, I guess the last demo I can show you is I mean, at this point, it's not as awesome as it looks now. So, demo, Zig build, right? Same thing, but I could do I think Arch64 Linux, V8. So I'm compiling for the Raspberry Pi, right? First time I do it, it takes a while, but now it's done, right? And also in release fast mode, now I can SFTP to my Pi, which should work. Please work. Please work. Yeah, connected to Pi. The Pi is right here. So I'll put 10. Cool. Upload it. So I'll SSH it to my Pi. So I'm running a Raspberry Pi. It's Ubuntu. I could do lsb _ released SA, right? Ubuntu cat proc CPU info. Yeah. So it's running Arch. Sorry, it's running ARM processor. That's all I wanted to show you there, right? So I have a 10. If I look at what 10 is, it's an ELF 64-bit AR64, and then I could run 10, right? Just works. Yeah. Cool. Anyways, and what's good about this is I think strace is a thing here. Yeah, strace -10. So as you can see, it's not even calling libc. It's calling the system calls it directly. So unless I'm linking with libc, right, you're not even, so this is statically compiled. That's what I want to tell you here. It's like, if this were a libc compiled app, right, you would see a lot of like DL open and all the fun stuff. But it is literally calling the exec v, exec v is called by the shell, but like it's literally calling the write system call to the Linux kernel directly, right? So that's pretty awesome. And that's how like the MSVC stuff works too, and all the other stuff. Now I could compile it for like GNU, right?
How big is it on the die?
10 is, it's 525K, but I don't know why that is. Did I even do a release fast? Yeah, I did. Could be something. I don't know why it is, but like, and so tiers, that's what I wanted to talk about. Yeah, the game is something else. So Zig has a tiered support system. So, it supports tons of platforms, but like x86, 64 in Linux is tier 1, everything is tested, everything is being worked on, yada yada, fun, right? Like Linux, Mac, Windows, and then ARM 64 is tier 2 in certain operating systems, tier 3, and WebAssembly 32 is tier 2 in WASI, which is another interface that you can write for, and for freestanding, which is in the web browser and other WebAssembly environments. So it supports all of these out of the box, but like when you're dealing with tier 3 and tier 4, you can generate an object file. So let me show you what I mean by that. So vim small.zig, right? I'll just do extern. Is it extern or export? Yeah, export fn, right? Start function void, right? You're going down into the weeds now. Now what I can do is zig build obj, all right, small.zig target will be AVR freestanding. It will happily generate a .o file for you, and then you can use a linker and compile it and run it on your Arduino now, right? That works, but like big. Yes. Yeah. So it's really so you might even like this. So Zig has this thing called translate C, and then I can literally translate C to Zig. Like it's, again, as I said, like once it's 1.0, this will work every time, but until then, there are still some rough edges. But yeah, like.
Is it just constant code, or will it translate logic?
It definitely will translate like big code. I think that's how what is implemented. So there was this. So I worked on the WebAssembly stuff, right? And there were a lot of like nasty C code that everyone else depended on. And what I did was did translate C on each of those and then cleaned everything up. That's how I worked. And something also I want to show here is let's look at the Oxid code. So src, let's say cat or view src platform, right? OpenGL. So let's look at some OpenGL. I think shaders is the wrong thing. Frame buffer. So this is how you can import a .h file from C. So .h C file essentially. So this will just import it into your Zig file. It would go through translate C and everything else, but it will work. That's all you care about. It'll work, and you can call C functions directly as if it were like regular functions in Zig, which there is no difference. So yes, I think that's about it. I think I went through a lot of stuff. I hope you'll give Zig a try. And time for my last slide. Sorry.
If you have a large Zig project with lots of modules and tests, is there a way to say test?
Oh yeah, totally. So Zig, let's look at the help. Yeah, there is a test filter, and then there's like 4 different test options, and more. Zig test has its own like sub options somewhere. I don't know. Anyway, It's there, it's massive, like, you know, and it's out to replace C. It's not kidding, right?
Definitely like the fact that they put the tests right.
Yeah. And I showed you the targets. Now there is also built-ins. And as I said, Zig has awesome like compile time, compilation. You can reduce massive chunk of code that would be compiled at, that would execute at runtime and convert it to compile time. So there's all of that built in. So Zig also gives you a lot of information when you're compiling the code. So like you can be like Zig, what's my architecture? Yeah. What's the endian I'm compiling for right now? And like, you know, you could switch off these at compile time. And also if you wanted, you can embed this in runtime. But like, you know, it's awesome. Like everything is well thought of, and the people that are like working on the language or like, you know, helping with the language know what they're doing. So like even for like package maintainers, right? Like so the way Zig compiles is Zig is supposed to have 3 stages. The first one is written in C++. That creates what we have right now. We don't have stage 2 or stage 3 yet, but what will eventually happen is once stage 1 is complete, right, the language is complete, then we'll work on stage 2, which will be written in Zig, and the stage 1 will compile stage 2, and the stage 2 will compile stage 2 again, and that will be stage 3, right? So, like, you know, it's self-hosting. That's what I'm getting at. Yeah, there's a lot of fun stuff here. Any questions? Yeah, I was going to show you since 2015, but like. So right now they're working on async await, which are coroutines, and it's awesome. I was playing around with it last night and trying to get. So I worked on the WebAssembly stuff quite a lot, and you can represent like you know, the promises in JavaScript inside Zig with async await functions, and that's pretty cool. And you can build your own event loop, and this might be exciting for you guys. Is you can build interrupt handlers with async await code and coroutines. So like, you know, it's just so difficult in like any other, in C essentially. But like you can do it in Zig.
So async await is built in?
Yes, but async await is, it's not as complex as any other language. So let me show you. Again, this is subject to change, right? It just became useful like, you know, a few weeks ago. But what you have is something called a frame, right? The frame of a function that you store somewhere. Could be in a heap, could be in a stack. It's up to you to decide. And also something else. Zig does not assume that you have a heap at all. So if you ever have to use a heap, you would have to allocate it yourself. So like, you know, if you're doing malloc in C, right, you can't always assume that direct allocator. Yeah, so you can't assume that like the memory that you asked for is going to come back to you, right? Like you might have run out of memory. So most of the functions that allocate will ask for an allocator. So this is, yeah. And the good thing about allocators is allocators can be different based on what you're doing. So you can have a fixed memory allocator, right? You can have something on the stack and treat it as a, you know, a global store and pass that to the functions that you care about. And like, you know, you're not touching the heap at all. You can fake having a heap, right? And all your functions will just do the right thing. And there's something else that I was just introduced to with Zig is something called an arena. And maybe you guys are just used to it, but like you can have, suppose you're dealing with like tree-like data structures, right? Lots of allocations going on, but the allocator is only like, you know, there is a single root to it, right? So once you're done with it, you don't have to go one by one and clear it. You can just delete the whole chunk, right? Because you're done with whatever you're doing. And those are called arenas, and there is a arena allocator built into the language. So like, you know, you want free for any of that, because most of the time you won't. And like when you free, you will just like, get rid of everything, and it will still be perfect. So like it gives you a lot more control, and it does not even expect that you have a standard library or anything in it. You can, all of the standard library is implemented in Zig. There is literally nothing, yeah, I can say that. Yeah, there is literally nothing that's in the standard library that you cannot write yourself. So async await, yes. So functions can resume and suspend. So instead of like returning once, it will just like suspend at a suspension point, and then you can call it later. So that's all it does, but like, building on top of those things. So suppose I have, I'll give an example of like JavaScript, right? Suppose I'm calling a web request, right? I'm doing a web request. I will just suspend at one point and then await sometime later, and then like, once that request comes back, I'll just continue wherever I left off. So I could just like write await code, and then, it's still doing the right thing, right? Like suspending and resuming, but it just works. So it's like having an event loop, and there is going to be an event loop in the standard library, but you don't have to use it. You can build your own event loop. And in the case of like JavaScript, right, JavaScript itself acts as an event loop. So like the code might be much simpler in that case, and in like low-level hardware, the interrupt, the CPU interrupt controller might itself be the event loop. So you can do some pretty cool stuff with it. Yes, so yes. But Zig also has the defer and air defer keyword. That's how you do memory management if you're used to like Go or something. That's something I might be able to explain it right now. So defer, yeah. So the way defer works is like right before it returns, it executes the statements in the reverse order. So usually what you would do is, so suppose you are like allocating memory, you would alloc and then write defer free right away, right? That won't get executed until you reach the end of it. But like if you're passing the thing that you allocated at the end, or like if you're returning at the end, then you do an air defer, which means if I errored, then execute whatever it was. So like if I didn't complete the whole function, right, then I would like, again, go back to like each function and then execute those air defer statements. So it's an alternative to what C++ does and has a lot less complexity, but it requires you to do the whole thing yourself. So like Zig has manual memory management. It does not have automatic memory management, which might be a good thing based on what you're doing.
That's pretty exciting.
Yeah.
I think it may be more than just a C replacement.
Oh yeah, and it has to provide something more than just like, be a one-to-one replacement to C. It has to do certain right things, provide like more guarantees, more ergonomics, and I think it's doing awesome work in all those fronts.
Very good.
All right. Thank you so much. Yeah, so last thing I wanted to say was, sorry, I forgot. So ziglang.org, GitHub, and then we're also very active on IRC on Zig Freenode and Ziglang on Twitter. And what I would hope from after giving this talk is like you guys play around with it and let us know like what's missing, what could be done better, right? I personally went through a lot of like linker issues because I don't know how linkers and like bootloaders work, right? So I could compile .o, but like I couldn't figure out how to like get them on those devices. So yeah, I hope to learn from you guys too.
I hope it works out.
All right, thanks.
We got about 15 minutes, I think. So
Yeah.
what we chat. We'll get out of here in 15 minutes. Thanks everybody for coming,
All right,
especially you.
I'll be around.